BCers, we're going to do the Unit 12 free response questions so that you have a video so you can go back and do more and more and more and more and more of them. So you're ready for question number 6, this BC question that's either a question about convergence, divergence, or Taylor series. We walked through some of these during the last study session, so maybe we just try them again. Might need some space on this, so we'll see. All right, it's nice of them that they gave you the Maclaurin series for 1 plus x. So you don't have to find it, but honestly, those are easy points when they ask you to find it. Write the first 4 non-zero terms in the general term for the Maclaurin series for f. F is x times log of 1 plus x over 3. This is one of those compositions, like log of 1 plus x. We need to turn it into x over 3. Well, I'm going to take my x's and divide it by 3. And then I need to multiply by x. So it's actually kind of easy, and it's important to look for these compositions as not being like super intimidating. We just need to take all of our x's and divide it by 3. And then we need to multiply all of these by an extra x, like distribute an x in. If you want to keep it simple, keep it simple. That is the first term. It's like the x over 3 is composed times x. If you want to write it as x squared over 3, that's fine. This is x over 3 composed times x over 2. This is x over 3 composed times x over 3. This is x over 3 composed times x over 4. We get to the nth term. Don't let it freak you out. Just keep everything the same. This is how we alternate, starting with n equals 1, n equals 0. Starting with n equals 1, so I have negative 1 squared. That's how I get the positive value. I have x over 3 to the n over n. That doesn't change, and then I multiply by x. I just do the same thing, and I get the answer. Now, we need to determine the interval of convergence for this Maclaurin series. For f, this is where it gets tricky. You have to use the ratio test. Whenever you see an interval of convergence, we use the ratio test. So to use the ratio test with this, it might be easier to simplify it, but let's pretend we don't. So let's do the ratio test. Ratio test says, as we look on forever and ever and ever, does the next term divided by the previous term always have a ratio that's less than 1? Now my nth term is negative 1 to the n plus 1 times x over 3 to the n over n. Okay, so that's the a-nth term. The a-n plus first term would just be replacing n with n plus 1. So they become negative 1 to the n. And it might be easiest also to separate these and simplify them. But for right now, it's not. This is n plus 2, x times x over 3 to the n plus 1 over n plus 1. And that's going to be multiplied by the reciprocal of this because you're dividing. Okay, now we look to simplify this and ensure that this is less than 1 as we plug in infinity. So I'll have negative 1 to the n, negative 1 squared. I'll have negative 1 to the n times negative 1. This negative 1 will go away with the absolute value. These negative 1s will go away as well. So it's almost like all of that goes away. I have this x that will cancel with this x. That's nice. I have x over 3 to the n and another x over 3. That x over 3 to the n will cancel with this x over 3 to the n. So that goes away, leaves me with an x plus 3. And then I have n over n plus 1. And a lot of people get to this spot and they don't know what to do with this. But don't forget, we need to plug in infinity, and then we get this expression. When I plug in infinity, this turns into 1. So I just get x over 3, absolute value has to be less than 1. So that's the whole radius of convergence is 3. And x's have to be between 3 and negative 3. And that's most of what we need to do. The final step, you'll get a lot of points just for doing that, is to check your endpoints. Typically, one of them is going to be a harmonic, which won't converge. The other one's going to be alternating harmonic, which will. So we got to go back to our nth term. We plug in 3. This is like absolute convergence. Now we're going to check for conditional convergence. When I plug in 3, I get negative 1 to the n plus 1. 3 over 3 is just 1, so this just turns into x over n. I think about this. Oh, sorry, this is 3 because I plugged in 3. I think about this, and it's going to be compared to the harmonic series. It is an alternating harmonic. I'm not sure if they'll accept this, but you could try. It converges since it's an alternating harmonic. If you want to actually prove that an alternating series converges, you have to make sure that they alternate, make sure the terms get smaller, and make sure the terms are trending towards 0. Like the next term is smaller than the previous term. I'm going to just hope that we don't have to worry about that. Usually nobody gets the credit for that, and we just have to focus on finding if it's harmonic and not harmonic, or hoping that it's harmonic and saying harmonic often. All right, now if I plug in negative 3, I got that negative 1 to the n plus 1. I got a negative 3. Then I have negative 1 to the n. Over n. Now, this is interesting. This is negative 1 to the n plus 2. No, false. 2n plus 1. Okay, now we're in business here. That's what I'm looking for. Think about what happens if you plug in 1, 2, 3, 4. And it's also good that you can check. You can also plug in 1, 2, 3, 4. Think about plugging it in for n. If I plug in 1, I get negative 1 squared. So that's just positive 1. And I get a negative 1 to the first. So I get a negative times a negative. I got 3 over n. If I plug in 2, I get negative 1 cubed, which is negative. That's a negative 1. This does not go, this goes away. That's a positive 1. Negative times negative 3 is a positive. What you'll see is like every single time you plug in a value, you're going to get an odd number. 2n plus 1 gives you an odd, which means it's not going to flip-flop. The fact that you have this 2n means you're going to take negative 1 to a same type of power, odd versus even. So negative 1 to the third is negative. Negative 1, plug in 2, you get 5. Negative 1. Plug in 3, you get 7. Negative. You get what is essentially the harmonic series. This simplifies to just be positive 3 over n. This is the harmonic series, 1 over n, 2 over n, 3 over n. This is a harmonic series that diverges. So, negative 3 diverges, positive 3 converges. This is my interval of convergence. Let's go ahead and check this stuff out, making sure we're doing this right. You can always do stuff. Okay, we got this. They simplified it. Boom, you get 2 points. 5 points. Getting the radius is 3. Sets up the ratio, 1 point. Computes the limit of the ratio, which means the n over n plus 1 goes away. That's a point. Considers both endpoints. Just considering the endpoints gets you a point, okay? Analysis of interval of convergence. So boom, 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 right? -3, not included, 3 included, 5 points. Okay? 5 points. So just like remember to go through all of the steps of the ratio test and you can earn a lot of points. And the ratio test is something good to practice when we practice last class. All right. We have a 4th degree Taylor polynomial for f. So this would be P4. It gets to the 4th degree and it's 4 terms. That's not always going to happen. Actually, false. Hold the phone. 4th degree gets to x to the 4th with this. This is nice of them because, like, you'll see why. This would be the 4th degree Taylor polynomial. X cubed times x to the 4th. Use the alternating series error bound to find an upper bound for the P4 minus 2. This is the idea of like alternating series error. It's all about the next term where every single time you add a term, you're going to jump over your sum. So you know that your error is within this distance. Like your this value is within this distance between here and here of the sum. So like you just plug in 2. This would be like the 4th sum. Boom. Like P4 of 2 is plugging in 2 here. That is gotta be, and that's like first term minus the second term plus the third term. That's gotta be within however much we're subtracting the next term by. So this has to be less than 2 over 3 to the 4th over 4. This plugging in 2 would give us our approximation for f of 2. We are within this much. Now, on the scoring guidelines, yeah, use the 5th term and your answer. So I used the 5th term and I got my answer. 8 over 81, 2 to the 5th over 3 to the 4th over 4, bingo. Okay? So, you know how to do the ratio test, you get a lot of points. Crush the AB questions. You're good. Got to get used to notation. Notational for derivatives. F to the n is the nth derivative. Here, this is interesting because they're doing f to the n plus 1. That's talking about like the second derivative will be equal to negative n times the first derivative. Just being able to plug in values for n, very, very important. Let me show you what they mean by that. First 4 terms, these are the n derivatives. Maclaurin series, just make sure you have the idea of the Taylor series in your head, where it's like we start with a point, we have our first derivative times x, we have our second derivative, x squared, don't forget to divide by 2 because of the power rule. Continuing on, the third derivative has to match. Don't forget to divide by 3 factorial or 6 because 3 and 2 and 1 will come down when you do the power rule. Okay, so f of 0 is 0. F of 1 is 1. So that goes here, 1. We need to show what the second derivative is. I will plug in 1 for n and get f2, 0 equals -1 f1, 0. The second derivative is the opposite of the first derivative. The second derivative is going to be -1. Okay, boom, that matches. You need to show plugging in 2. If I plug in 2 for n, I'd get the third derivative equals -2 times the second derivative of 0. The second derivative was -1. Multiplying that by -2 gives me +2. So I have +2 x minus 0 cubed over 3 factorial. The 2's will cancel. It just gives me that. That's good. Okay, 1, 2, 3. We need to do the next one. The fourth derivative, this is when n is 3, equals -4, sorry, -3, n is 3. Fourth derivative equals -3 times the third derivative. The third derivative was +2. So the fourth derivative would be -6. The 6 will cancel with the 3 factorial and just leave a 4. You need to write the general term. It's a little tricky, but like do your best. You can see the power and the value are aligned. So I'm going to say it's x to the n over n. I need to alternate. If I plug in 1 to start, we need a positive. So I'm going to do n plus 1 to make sure I have -1 squared for the first one. And then I'm good. Determine whether Maclaurin series described in part A converges absolutely, converges conditionally, or diverges. So it converges conditionally, and it's because when x is 1, you have the alternating harmonic series. Again, like understanding the harmonic series, diverges if you're adding, converges if you alternate. 1 plus a half plus a third plus a fourth actually diverges, goes to infinity. But alternating them, boom, it converges. So conditionally, it's the alternating harmonic. I wonder if they accept that, or you have to show more. Let's go and look in the things. Like, do you have to say that it converges? Because it's an alternating series, the terms decrease and they trend towards 0. Do you have to then look at the absolute value and say, okay, this is the harmonic series that diverges, or like, is this okay? So 2017, number 6. Yeah, so like the series does not converge absolutely because the harmonic series diverges. So the fact that you mention harmonic series is good. You can say a harmonic series diverges. But then you do have to say that the terms alternate, they decrease in magnitude to 0, and therefore it converges conditionally. The alternating series test, you have to say your terms are decreasing, they trend towards 0, and they alternate. Those are just the 3 things you have to write. I like how they wrote it here. The terms decrease in magnitude to 0 and alternate. That covers all 3 things. Write the first 4 non-zero terms in the general term for g of x is the integral. So you just have to take the antiderivative. So antiderivative, you have them. This is a minus. It's easy to just do this. Okay, let's talk about that one. I add 1, I multiply by the reciprocal. I'm still dividing by n, I'm still alternating. That works. You gotta practice it, it's not that bad. That works. Alternating series error bound. We're talking about they didn't tell you, but you're using the 4th degree Taylor polynomial to approximate this g value of a half. So if I plug in 1/2 into this, I'm approximating a value, a sum. If I am using a 4th degree, that would be using these 3 terms that takes to a 4th degree. Alternating series error has to be within the 1/500, which you're going to just assume is less than this with 1/2 plugged into it. You can't check, you don't have a calculator, you just go with it. And it's true. 2, 4, 8, 16, 32 times 20 has got to be bigger than 500, you win. Getting the 2 terms, getting the remaining terms, getting the general term. 3 points, guys. It's not bad. Like, we could do this if you just try. Getting the error bounds just 1 point. There it is. 1/2 to the 5th over 20. Not sure if they accept it, just like writing that, but looks like it. All right, let's do 3. Let's get to 6. 6 problems. Okay, nth derivative. That's term for nth derivative. Get used to that. It's not bad. Okay. Taylor series centered at 1. Don't mess up. F of 1 plus f prime of 1 times x minus 1. Don't forget that. We're centering it at 1. That's like the important point that needs to zero out. Plus, I need my second derivative. So I'm going to plug in 2. 2, 2. It's a positive 2. I mean, it's easy to simplify this, but we get 1 factorial over 4. Don't forget to divide by 2. This is the nth derivative. Like, if you need to write this out, you got help if you do. Okay. First 4. I got 3 down, so let's go for the third derivative. It's going to be a minus 2 factorial 8 3 factorial. General term. Nth derivative, x minus 1 to the n over n factorial. Literally, you got what you need here. Nth derivative x minus 1 to the n over n factorial. You can separate it into multiple fractions, or write this next to this, write that next to that. Part B, you kind of have a lot of what you need. You don't have to use the ratio test. They tell you what the radius of convergence is. Radius of convergence is always centered around 1. So that means we're talking about going up to 3, or possibly down to -1. So this is absolute convergence. So we just need to check our endpoints. Check x equals 3. All right, I'm plugging in 3 here. I get -1 to the n. I got 2 factorial. I got 2 to the n, which is going to cancel with this 2 to the n. And I have n factorial. 2 to the n's cancel. We're alternating. Yo, you see n factorial in the denominator? Factorials are one of the fastest growing functions, so that means my terms are going to quickly go to 0, very quickly. This definitely converges. You could say it converges because it's alternating with magnitude decreasing to 0. Love that. Converges, they're alternating with a magnitude decreasing to 0. If I check -3, I'm going to get everything's the same, except I'll have a -1 attached to it, which means it'll, this is -1 to the n times 2 to the n, so these will cancel and be a positive. 2 to the n's will cancel, so I'd have 2 factorial over n factorial. Also converges. Now to explain why it converges, that's when it's tough. You can do a direct comparison with 1 over n squared. It would go to 0, which is a, no, that doesn't work. Oh man, I don't know how to prove that that converges. Let's see what they put. But all you have to do is like, they both converge, so you should be including -1 and 3. Let's check. 216. Look at that, 4 points for part A. Yo, that's not bad. Like, it's important. Important to see that. Yo, 4 points for like the easy part. Part B, hard part. Identifies both endpoints. That's worth 1 point. Getting this extra point, that's tough. Oh, I messed up though. Oh, because it's not n factorial? Because the n factorials cancel? Oh, I forgot about this n minus 1 factorial. Yeah, my bad. It just like disappeared on me. N factorial is equal to n times n minus 1 factorial. So this actually cancels with this and just leaves you with n. So this should just be n. And this is n, and that actually makes it easier. Converges, alternating series, diverges, harmonic series. You don't have to prove that the harmonic series diverges. My bad. So -1, we are going to diverge. But man, look at that, 4 points for this like first deal. Not bad. You don't even have to have the simplified one. All right, part C. Taylor series can be used to represent f of 1.2. Use the first 3 non-zero terms to approximate f of 1.2. It's not bad. All we need to do is just plug in 1.2 into the first 3 terms and leave it unsimplified. Okay. We get 1 point for that. You don't have to get the value. You leave it like that. Alternating series, error-bound. Again, like literally every single question in the last 3 years had alternating series error-bound. So you're using 3 terms to approximate a value. It's got to be within the next term's amount. The next term is that. So 2 factorial, 1.2, probably have to be like my second degree at 1.2 minus my actual value of 1.2 has to be within 2 factorial over 8, 1.2 minus 1 cubed over 3 factorial. Now they're saying like, oh, you have to like show that this is a convergent sum, and then you're using the alternating series error bound. So since it's an alternating series, this is why we're using the alternating series error bound. So this is why like they have this like, it's an alternating series whose terms decrease in magnitude towards 0. And then we use the alternating series error bound. You get 1 point for this error form. The 2 factorial cancels with the 2 factorial here, leaving a 3 and the 8, which is 2 cubed. Boom. And you got 0.2 to cubed. Yeah. Boom, ratio test. Gotta do it. Big point. Big points for the ratio test. Just trying it. Getting it mostly right. All right, so limit as n approaches infinity of the next term divided by the previous term as we look on forever and ever. Has to be less than 1, and your terms are going to converge. Your series will converge. We have the nth term. We need the n plus first term. Negative 3 to the n plus 1 minus 1, which is just n, over n plus 1, x to the n plus 1. All right, so that's my n plus first term. I need my nth term to be divided, so flip everything. N comes to the top. Negative 3 to the n minus 1, x to the n comes to the bottom. We need to simplify. This goes away. Let's use some exponent rules. We did this in class, but like, try them again, right? I got negative 3 to the n. This is negative 3 to the n, and negative 3 to the negative first. That goes away, that goes away. That brings up the negative 3 to the top. I got an n over n plus 1, which is going to go to 1 as you plug in infinity. I got an x to the n. I got an x. I got an x to the n. That's going to cancel. So this ends up being negative 3x. So at negative 3 to the negative first brings this up. The absolute value takes care of the negative, and you just have my radius of convergence, which is a third, which is the radius of convergence. This is 2015. And it's only 3 points. Sets up the ratio, computes the limit, determines the radius of convergence. So making sure that at some point you show that this n over n plus 1 goes away. 3 points, I've seen it worth 5. All right, write the first 4 terms in the whole rational function is rough. First 4 non-zero terms are not that bad because you get that when you point the 2 down. You get that. You can go ahead with the next one. Is going to be 27x cubed. If you guessed. Write it as a rational function. This is cruel, but it is important. You notice there's a common ratio. There's an r. You just keep multiplying by negative 3x. Well, the geometric series can show it has a sum, which is your first term times 1 minus your common ratio. 1 over 1 minus negative 3x would therefore be my rational function that equals this alternating series. Not nice. They gave you 2 points for the first 4 non-zero terms. So, I mean, we should have talked about this during class, during our tutoring session. Like, there are easy points to earn. The hard points are worth less because usually people don't get them. This, I remember, is a cool one. You get easy points. We should remember e to the x is Maclaurin series, sine, cosine. Okay, those are easy ones. They're all very similar to each other. They all have slopes, derivatives at 0 that are 1. Either cosine and sine alternating and skip some because you have zeros, but e to the x, all the slopes are 1. So, like, you need to be able to write e to the x's Maclaurin series easily because all of these slopes are 1. 1, 2, 3, 4. All right, and it keeps going. Now, we want to write e to the x times f of x. Here's my first 4 terms. Times f of x. Wait, f of x, not f prime of x. This showed up and blew everybody out of the water the year that it came out because you'd never seen a composition like this. We're used to having like an x being before something. When you're multiplying by x, you just multiply each of these terms by x. We're used to multiplying things by numbers or x to a power, but never by this function. Why this blew people out of the water the year that it showed up is because students didn't think about how you have to distribute. And like realize all the different ways to get, you know, your x term, your x squared term. I have an x squared, but I also have negative 3 halves x squared, which I need to combine to be like negative 1 half x squared. You can consider this your second term. But that's x to the 4th. Oh, no, that's x squared. I need x cubed. What are the different ways to get x cubed? Well, 1 times 3x cubed. X times an x squared. X squared times an x. And this would be like your third term. You combine them. Really, really mean. See, like having this distributed and then like, oh look, it's just negative 1 half x. Yeah, negative 1 half x. And this is 3 minus 3 halves plus a half. So it's 3 minus 1 1/2 plus a half. So it's 3 minus 1, which is 2. Yeah. Really mean. But like you do these more and more often, you get used to them. 2014. Let's do 2 more. Yeah, let's go to 7. These are fun. We got time. Tomorrow's tutoring session will just be parametric and polar free response. And then more of these. We'll do more of these. And then Sunday, same thing. I have to teach you about logistic differential equations. Yeah. What's the value of R? You gotta use the ratio test. If you look on forever and ever, the next term divided by the previous term has to be less than 1, and you're going to converge. You're going to get a sum. This is our nth term. Let's write out our n plus first term. Negative 1 to the n plus 2, 2 to the n plus 1, n plus 1, x minus 1 to the n plus 1. And that's going to be divided by a to the n, or multiplied by the reciprocal. So I got negative 1 to the n plus 1 is on the bottom, 2 to the n's on the bottom, n's on the top, x minus 1 to the n's on the bottom. The limit as n approaches infinity has to be less than 1. Good practice, just keep doing these. That's gone, that's gone. This will go away with the absolute value. Honestly, you don't have to care about any of the negative ones when we do this. Just worry about the 2 to the n's. Gone and gone. We got the n and the n plus 1. If you plug in infinity, this goes to 1. It's important to do that. And then the x's. Plug in infinity, this goes to 1. You get just this 2. So 2, x minus 1 has to be less than 1. My radius, therefore, is a half. Okay, let's see how many points that was worth. Three. Not many, not many. Not many. Not many. This part is easy. First 3 non-zero terms in the general term. You have to be able to write out f and then write out f prime. So that's a little mean. So we got to write out f. Now it's like, this is the Taylor series. These are the terms of my Taylor series. These are not the nth derivatives. They're giving me my terms. They're starting at 1. Here we go. Positive 2 over 1, x minus 1 to the first. Alternate signs, 2 squared over 2, x minus 1 squared. Starting at 1, so there's no like 0 term or function value, it must be 0. Alternate, plugging in 3, 2 cubed over 3, x minus 1 cubed. General term, negative 1 to the n plus 1, 2 to the n over n, x minus 1 to the nth. Now let's take the derivative. So here comes f prime. We're just kind of taking the derivative of the outside. Like the derivative of 2, x minus 1 is just 2. This 2 is going to come down and cancel with this 2. Still going to have the minus, so I have 2 squared x minus 1, because this 2 comes down when I take the derivative. 3 comes down when I take the derivative. I'll just have 2 cubed x minus 1 squared. Okay. First 3 terms, general term. Here we go. We're still alternating. The n cancels with this n, so the n goes away, and I subtract 1 from the derivative, like the power. Power rule is bring the power down, subtract 1 from the power. Boom. There's the first 3 terms in the general term. We get first 3 terms in the general term. 2, 4x minus 1, 8x minus 1 squared. I wonder if they did it an easier way. I guess you could take the derivative of this. Honestly, instead of writing out f and then writing out the derivative, you could just have gone straight to the derivative of this and say, oh, this end comes down and you subtract 1. Here's the general term, and then you fill out your terms from there. Geometric series shows up again. This is like the one sum that you have to know, is that if you have a common ratio, sum of a geometric is my first term over 1 minus r. What's my common ratio? I'm multiplying by 2 and x minus 1. And my first term is 2. Find the function f prime to which the series converges for that. Use this function to determine f. Okay, so this is what I think is f prime. 2 over 1 minus 2x minus 2, which becomes 2 over negative 2x minus plus 3. So distribute this negative. Okay. That's f prime. Use this function to determine f. I'm going to take the antiderivative. Log 2 log absolute negative 2x plus 3 should be a plus c. I feel like there's something about that plus c, which just leave off because I don't know where that would come into play. Don't forget to undo the derivative of the inside with a negative 1/2, which means f is probably negative log absolute negative 2x plus 3. Oh, the ratio is negative 2. Oh, I messed up. My bad. This is negative 2, which will make that all screwy. My bad. My bad. Multiply by negative. So, also positive 2x minus 2, 1 minus 2 is negative 1, 2x minus 1. So the antiderivative, therefore, is 2 log absolute 2x minus 1. Divide by 1/2, it's just log absolute 2x minus 1. You get f prime, you then take the antiderivative, or at least attempting. Oh, yeah, there's a c. Nobody's getting that. F of 1. Oh, that's tricky. There is a c. I knew there was a c. I knew there was a c. And they're like, what's c? Well, it's like, what's f of 1? There was no first term because, like, f of 1 had to be 0 for this Taylor series to start with 2 times x minus 1. That's so fun and tricky. C is negative 1. Oh, that's so... Wait, C is 0? F of 1 is 0. Oh yeah, this is 0, C is 0. Okay. I don't know if like they expected you to do that, but that's fun. All right, number 6, 2013 BC, number 6. Nth degree Taylor polynomial. this is tricky. They're saying my first degree Taylor polynomial, when I plug in a half, equals -3. I don't think I've done this problem. Okay. Here's my first degree Taylor polynomial. F of 0 about x equals 0. We're talking about a Maclaurin, so f of 0 is -4 plus whatever my first derivative is. I don't know what it is at 0 times x minus 0 squared, or times x divided by 1. Okay, this is what my first degree Taylor polynomial is. Now, you can't just plug this in and say, look, it works. It's like a fallacy in mathematics to like plug something in and be like, oh, since this works, then it must be true. This is what you start with. You know this. Which still means you don't know f prime of 0. And that equals -3. There you go, solving for this by multiplying by 2, and you get f prime of 0 is 2. That's what wanted to be shown is shown. That's mathematics. I don't know if you're getting that. I don't know if anybody's getting that. I mean, some people are getting that. A lot of people don't know that you, until you take a more advanced math class, you don't realize that you're not allowed to use this. You're not allowed to use this. I guess if you did like proofs in pre-calculus or in geometry, to show something, you can't use it. You got to get there. 2 points. Uses P1 of x, which is that, and then verifies, but only 2 points. Because it's hard. On AB, usually the harder parts are worth more. It seems like on BC, the easier parts are worth more and the harder parts are worth less, because they know so few people get the harder parts. All right, well, P of 3 is easy, because I already know first value. Now I need my first derivative at 0 times x. So my first derivative is 2. They just kind of told you that. Then my second derivative is -2/3. So I need my second derivative at 0, x squared over 2. Don't forget to divide by 2. And then my third derivative is a third x cubed over 3 factorial. Again, you can put the 2 next to the 3, you can put the 3 factorial next to this 3, but that's it. Yo, that's 3 points! Getting the first 2 terms, getting the third term. Literally like, first 2 terms, third term, fourth term. Literally remembering dividing by 2 and 3 factorial. I'm sorry I didn't bring this up on Tuesday. It's like, forgot that this is how it was done. Sometimes the easier parts are worth easy points. Okay, f of 2x, find h. Okay, I gotta think about this. This is f. This is approximating f. Okay. There's 2 ways to go about this. H prime is going to be equal to f of 2x. Here is f of 2x. I'm composing. Told you before, composing, important. And simple to do, as long as like you don't try to simplify. Okay. Now to find h, and I only want the third degree, which means I'm only going here, I know h of 0 is 7. This is the whole idea of our first value. That's the c value. When I'm taking an antiderivative, I need a plus c. So there's my c value, and then negative 4x, and then I have 4x, which becomes x squared over 2. Now this will be the tricky one because this is negative 2. I have 2 squared, x squared, 3, 2. The 2's will cancel. Antiderive, it's x cubed over 3, so that becomes x cubed. This becomes 3 squared. That's my third degree. 7. Yeah. Here's one way. Here's the other way you could have done this. If that's h prime, here's h. The antiderivative of f with 2x plugged in times a half. You end up doing the same thing. Oh, that's fun where they use the derivatives. Oh, I like that. Anyways, you got 7 minus 4x plus 2x squared, got it. Minus, this is 4 ninths, x cubed. Boom. 4 points. Applies h prime equals f of 2x. I mean, there's me applying it. So I guess I'm plugging in 2x. Plugging in 2x is like that first thing. Using this 7, I don't know if they needed you to do that, but it was the whole idea of like, make sure you have a plus c. All right. Lagrange error bound has not shown up for a while. 2012. Hey, ratio test. Great. Listen, if you're ready for it, get some easy points here. Let's write down a to the n plus 1. I don't have to worry about the negatives. Ooh, x to the 2, n plus 1, plus 1, 2, n plus 1, plus 3. This is where we're going to have some things with like odd powers and stuff like that. Yeah, you see kind of odd powers here. It's 2n plus 2 plus 1, so that's 2n plus 3. 2n plus 2, 2n plus 5. We don't have to worry about the negative ones. They're going to go away. I don't know if you have to put them in there. This was a tricky one, I remember this year, because of this x squared deal. Gone, turns into x squared, goes to 1 as n approaches infinity. So you get this x squared has to be less than 1. You can't split it up and then square root. You just got to think like you still have to be between 1 and negative 1 for the value squaring to be less than 1. We need the interval of convergence. We need to check our endpoints. For conditional convergence, this is absolute convergence because we looked at the absolute value. So let's plug in 1. The negative 1 to the n is back. We just have 1. 2n plus 3. This is alternating series whose terms magnitude decrease to 0. Converges. Alternating, terms get smaller, terms go to 0. It is an alternating harmonic. I don't think they accept that. If you get x equals negative 1, though, now things are going to get complicated. Got the negative 1 to n, but now I have negative 1 to the 2n plus 1. I got to figure out what to do with that. All right, so I got negative 1 to the 3n plus 1. If I multiply those two things together, we add the exponents. 2n plus n is 3n. If I plug in 1, I get 4. If I plug in 2, I get 7. That alternates. If I plug in 3, I get 10. Plug in 4. So like plugging in 1, I get 4 positive. Plugging in 2, I get 7 negative. Plugging in 3, I get 10 positive. Plugging in 4, I get 13 negative. The signs are alternating. So this is also an alternating series whose terms decrease. This is not one of those situations where on one end it's going to be the harmonic and on the other end it's the alternating harmonic. These are both alternating series whose terms decrease to 0 and they converge. Part A for this 2012. Was worth 5 points. Woo! Sets up the ratio, computes the limit, identifies the interior interval of convergence, negative 1 to 1, considers both endpoints analysis. Just considering endpoints. Yeah, they're both alternating series. But this time they just say they converge by the alternating series test. And then in the later years, they're like, you need to say that it's an alternating series whose terms magnitude decrease to 0. Anyways, that's 5 points there. Part B. Okay, boom. It's like, this is an alternating series whose terms decrease in absolute value to 0. Using 2 terms, we get that. Okay, well, since it's an alternating series, we'll use the alternating series error bound, which is the third degree polynomial approximation of a half minus the actual value. It's got to be less than 1 over 200, which has to be less than however much I add to get to the next term. Adding 2 terms, I jump over my sum. However much I add, I know my actual sum is between that, so that is my max amount I'm away from it, which is 1/2 to the 5th over 7. Use the third term as an error bound using this notation. Oh, it's got to go the other direction. My bad. I messed up on the previous one too. This has to be less than this. Yeah, don't give up, right? Look at this. Part C, the easiest part, is last. G prime has to be 1/3 minus 3x squared over 5 plus 5x to the fourth over 7 plus dot 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 plus -1 to the n. Bring down the power, subtract 1 from the power. Here comes the power down, 2n plus 1. Subtract 1 from the power, you just get 2n over 2n plus 3. Part C is worth 2 points. Easy 2 points. I don't want to do this Form B question. We're going to use Lagrange error. It's all about the next term, but Lagrange error is all about like the max value you could get for your next term. Anyways, I'll show you when we get there. All right, look at A. Easy. Sines Taylor series. Sines Maclaurin series. Easy. I mean, probably not even read it. So sine of 0 is 0. So this is the one that starts out with sine's derivative, the first derivative, which is cosine, which plugged in 0 is 1. Cosine of 0 is 1. So this is the one where we start at x and we start skipping. They don't even ask you for the general term. Sine of x squared, compose. Compose. Don't simplify unless you really have to. Cosine. This is the one that does start at 1. Skips x, goes to x squared. Skips x cubed, goes to x to the fourth. Goes to x to the sixth. They're really leading you through this problem too. Use this series and the series for sine x squared to write the series for f. Sine x squared plus cos x. Add a and b together. Here we go. I got a 1. I got minus x squared over 2 factorial, and I got an x squared. So that's adding a 1. So this is a half. I think they want us to do a simplification here. I have minus half and I have 1, so I'll have positive a half x squareds. Right, because we're using this part and we're using this part. The next one I get is x to the 6th. I just want the first 4. So I got this taken care of. I subtracted a half x squared from this x squared. I have this x to the 4th, which is going to be by itself. And now I need to deal with this x to the 6th. How do they write that out? I feel like I made a mistake somewhere. X squared cubed. F is sine x squared plus cos x. Right, the first 4 non-zero terms. 1 positive x squared plus x to the 4th over 4. Got 121. How'd you get 121? I got negative 1/6 and then a 3 factorial. No, I have a 6 factorial. I mean, I think the best thing to do is like, I got that, and then I got that. I'm adding them together, and it's almost like I could do negative 1 over 6 factorial plus 1 over 3 factorial as the coefficient of x to the 6th. How'd they get that into 121? Sine x squared. Okay. Cos x. Adding this, I need to add this x to the 6 over 6 factorial and x to the 6 over 6 factorial. And then they got 121 x to the 6 over 6 factorial. I gotta ask half this. Look at that. 1 over 3 factorial plus 1 over 6 factorial is the same as 121 over 6 factorial. What? Oh, shit. I think I know. I don't think you're expected to do this. I like what I did here, which is saying I have to add these two. I got negative 1 over 6 factorial plus negative 1 over 3 factorial as the coefficient for x to the 6th. Now, what they did is they needed a common denominator. How do you get a common denominator? You need to turn 3 factorial into 6 factorial. You multiply by 6 by 5 by 4. 6 times 5 times 4. And that gives you 6 times 5 times 4, negative 121 over 6 factorial. Sons of bees. And then they ask you to find the 6th derivative. And that's mean, because like, you got the x to the 6th term, but times this weird thing. Negative 1 over 6 factorial and negative 1 over 3 factorial. And your 6th derivative over 6 factorial equals, I mean, listen, we could still work with this. Where you would say the 6th derivative of 0 is equal to 6 factorial times negative 1 over 6 factorial plus negative 1 over 3 factorial. They have to accept that. We kind of practice that. Oh, this is a tough one. Well, let's look at the point distribution. 6 points for just writing sine x and its composition and cos x. I guess they wanted you to like add the things together, which is the tricky part. 1 point for getting this answer, which was tricky. Now, error on a non-alternating series is still related to the next term. It's just you have to be within an amount of the next term, where the next term has a max value rather than a specific value. Like, here's the fifth derivative of x shown here. We're talking about between 0 and a fourth. I guess they want to say that the max is 80 between 0 and 1. And the fifth term uses the fifth derivative over 5 factorial. So the max of the fifth derivative looks to be, if you talk about a fourth, it looks to be like 40. 40 over 5 factorial? Is that what they did? 40? Oh, and then times your 1/4 to the 5th power. Damn. If you don't get Lagrange error bound, it's not bad. It was 40. They wanted you to do the max of the fifth derivative between 0 and a fourth. Between 0 and a fourth, it's like, it's got to be underneath 40. But it's like they didn't even give you a value to look at. This is the next term. Once form of the error bound. So that means this has to be less than that, which is less than that. And how do you know that? You're just going to go for it. All right. That's good, doing 10 questions. Got more, of course. Keeps going on until 1976. Probably better questions back in 1976, to be honest. But look, just A's and B's. So, happy to do more with you, like on Sunday, but this is a good 10. Lots of ratio tests, compositions, not being afraid, because they're easy points to be earned on these Taylor questions, okay? Later.